Move on. We're right on time to our second speaker. I need help with pronunciation. Is this Jelene Srebric from the University of Maryland? Please say your name for me. Speaking on building ventilation, occupants in the microbiome. Thank you.
Somehow I was certain it was me. My name is Jelene Srebric, but I go by any other similar name. So when I was first, thank you for inviting me, and I'm really honored to be here. I imagine a room, when I prepared this, imagine a room full of microbiologists, and couldn't even imagine how I could really contribute to the discussion. And I'm very happy that Gary did a really wonderful overview of existing pieces of work. I did the same thing, but I reframed myself from bringing that to the table. I ended up just giving my main observation from the current studies, and then I wanted to share a couple of findings from my own community, and also to encourage other players at the table to consider some of these issues that we found in previous studies. So, what I have found through my readings is that microbial communities are quite diverse. I worked with the microbial communities myself, sampling them, sending them to appropriate labs to do analysis for me. I'm also visiting faculty at the School of Public Health at Harvard, and I worked there with a couple of really nice colleagues who are putting up with me for quite some time. Steve Rudnick, Ed Nardell, Jack Spengler, and late Mel First. So everything that I know, it's really, my thanks go to them in terms of the sampling and analysis of the results. Reading beyond just the obvious finding that microbial communities are diverse, I also concluded that there is no agreement. And again, I was very happy to see that Gary's conclusion was similar, because there is a highlight on the importance of outdoor environments or outdoor microbiome, as well as human sources of microbiome indoors. But I saw very reputable journals and very reputable colleagues disputing each other's which one is more important. So I concluded that both are important, and I also concluded that they were looking at the different types of buildings. Without going into details about that, that was my general take home, and then I would like to share a couple of reasons why that would be the case. That you could even have the same method, same building type, within a half of a kilometer or half of a mile to a mile, and you can end up with a very different result. And the reasons are humans. The reasons are not that we are only the source, but the reasons are humans involved in the operation of buildings. So the exact same building occupied by different people end up performing very, very differently. So I will be talking a little bit about these confounding factors that end up overtaking the our approach to analytical science and reproducible, repeatable methods. So I'll talk a little bit about what human beings are doing to buildings. I will talk about a little bit the fact that not all buildings are equal, just between the types as well. I heard a lot of conversation whether we should study schools, homes, or other types of buildings that you will be guys deciding about. So the first thing that I would like to bring my attention to you is related to the famous study from EPA BASE. I'm sure a lot of you are familiar, 100 office spaces. I personally work in a lot of commercial buildings, so that's why I always reference that study and also benchmark my results. The success of that study, I think, comes from the fact that it, in a reproducible, systemic way, studied hundreds of buildings, or 100 or so buildings. And then, rather than just going into excruciating depth, which they also did, in different type of the studies, they also cover a lot of territory. EPA covered at that time, in the group that collected the data, covered mechanical system operation, covered indoor contaminants, covered occupant outcomes. And if you look now, that sounds very reasonable. At that time, that was really revolutionary concept because you covered building science, public health, even microbiology, and so on. So I think the success of that study was not just the sample size and how many different parameters we collected, because we found quite a lot of those parameters did not have any statistical significance in our analysis, and there was quite a lot of analysis. So with respect to that study, I would like to say that it's wonderful when you have money to do such a huge campaign that has such a profound impact on all of the air quality, indoor air quality studies. But it's also important to have case studies as well, because there are real buildings that can skew the sample. Also, there are things that we do not think up front or do not know yet. So it's a really nice way of kind of normalizing what community is doing, and then even having case studies to contribute to the baseline knowledge. And that was one thing that I saw about microbial studies or microbiome studies. I couldn't catch what really is the baseline microbiome and then all other interesting species that you would add on the top of it. So for example, I will have in my conclusions a discussion of that. So what I have done, other than analyzing the base study, and I ended up analyzing fungi and different type of results that were reported there because nobody else at that time was interested in analyzing that stuff. What a luck. And we have found that, and we also analyzed occupant perceptions on humidity, a perception of humidity, chemical and other odors as well as a smoke, a smell. And we have found that occupants are really good perceptors with respect to indoor air quality. And again, we have a paper discussing details, but we also found that biological contaminants or microbiome, maybe they are not contaminants, exhibited slightly lower statistical perception association with examined health outcomes or reported perceptions of human beings. Another thing that we learned there is that humans are really good perceptors in some areas. In other areas, they are just complainers. And they don't, I mean, we can tease that out and use our occupants as a really good instrument for screening, if nothing else. Again, whenever I don't have enough money to sample things, I do sample response from human subjects with appropriate IRBs, of course. We found in this study something that served us really well. So analyzing base, we found something that served us really well in the case study of this LEED certified building. And we have found that occupants cannot perceive indoor humidity. They perceive and report something, but it surely references to something else. And I'll give you why this case study provided full support of this finding. So with respect to temperature, many other things, they're really good perceptors. With respect to humidity, they're just complainers. So, including myself. So we have found, and the reason why we use this specific case study is, and compared it to base, and we repeated the protocol exactly it was done with the previous base study. Because it was a very nice building in Pennsylvania, and it has Department of Environmental Protection. So at that time, indoor air quality studies were not that popular, and this was a really good collaborator for us to find. And they had also very well studied energy-related study because they are LEED certified building. And we were interested to see how LEED certified buildings, or this case study, fare against the population of buildings in the United States. We have found that for this particular building, actually the study was done by my colleagues at NREL, the energy side, in terms of saving energy, and again, there is a lot in literature, and we can spend another panel just talking about that, that LEED buildings sometimes save energy, sometimes don't. And the reason are, again, occupants, and more particularly building operators and occupants combined. And that dynamic is really important. So I hope there are social scientists as well here. So we found, with respect to occupant perceptions and also self-reported health outcomes, this LEED certified building really performed or fared better than the base buildings, which was a really wonderful finding. We also found unfounded, in terms of the humidity, very high dryness of the air. So occupants were complaining about air being very dry, even though we measured no problems with the humidity level in the space. And that led us to a conclusion that that one must have been driven by a high level of PM10 or higher level PM10 than in other buildings, other similar base buildings. And then we further investigated where the PM10 would find, because they were very adamant about filtration. They were low VOC emission materials. The manager of the building is a phenomenal lady who really got invested in running this building right. So everything was going right for this building, and still failed in two aspects. First of all, we found high levels of PM10, and the most probable source that we never got to go back and investigate was occupants' clothing, because majority of the employees are mine inspectors, who would be coming back from the field studies on a regular basis and therefore polluting their own air with their own clothes. And most likely that complaint about humidity was related to PM10. The other thing that we found, again, as a conclusion, which was really nice, is that overall, other than that specific quirky source of pollution, additional pollution, they really had a better quality of the environment. So when we talk about LEED certified buildings, again, we can spend another forum talking about whether they are better in this or that and so on. There is a high probability that they really provide better environment if we cannot agree if they're saving energy, based on the perception of occupants. And they seem to be reliable in quite a few reasons. So that was discussion about office buildings and the existing study that we can kind of spring off follow-up studies. I would talk about purpose and place for case studies, as well as really big campaigns that require heavy investment of funding. Another campaign study that I was part of involved investigation of big box retail buildings. And again, I will make my case for occupants, again, with appropriate IRBs, even though they did not, they let us heavily sample indoor environments of 14 big box retail buildings, because ASHRAE was investigating opportunities, or is still investigating, Andrew can confirm, and I was very happy to see him here, opportunities for calibrating the ventilation standards. That's a big discussion, because the higher ventilation, the higher your utility bill. Everybody sees that as a great opportunity to reduce the energy consumption and so on. And one way to do and still be within the guidelines of the standard is to keep indoor contaminants diluted. So we all know filtration, dilution, or source elimination. And when it comes to dilution, it costs, everything costs, but it's a really easy thing. You just strike a number in the standard, you are in a new range, no problems. It's not that easy. We measured 14 buildings, different season, 24 field campaigns. And again, this is a mini field campaign study compared to what EPA did, but still it was a major effort. It took us 2 years and took us a lot of begging to let us get inside of these buildings and sample stuff, airflow rates, VOCs, aldehydes, particulate matter, canister collection of different volatile compounds and so on. Sloan Foundation also funded the follow-up study on microbiome, which was really fantastic because it's leveraged in existing funding. And we have found that buildings are clean, at least retail ones, with the exception of formaldehyde. And according to that finding, we can respectfully and reasonably reduce ventilation rates. But it's not always easy, and I will tell you why. Formaldehyde is relatively high. They're bringing formaldehyde themselves into the space. They know how, and they are committed to source elimination because nobody wants to increase ventilation rates. Because all other contaminants, usual suspects, including microbiome, did not convince them that they could reduce the ventilation rates. So, with respect to measurement of microbiome and ventilation as a dilution method also provides some insight on how the building is operated. So when you venture in sampling things, it would be really wonderful, and that's most of my proposals are like that, to really sample something about the operation of the building. Most of the buildings that were studied are, of course, residences, and this is just the ventilation rates. Offices and schools are other very well studied building types. So we positioned this particular retail study. Now we have these 14 buildings as a sample size. We found typical ranges for ventilation, and then we look into how does that compare to the standard, because you remember the purpose was to really kind of influence the standard. And we found that quite a few buildings are operating already below the standard requirement. They knew we were going on site, and it's not really their intent to ignore the ventilation standard, but a lot of people don't know what they are getting in their buildings. And it's a very tricky thing to measure, very, very tricky thing to measure. And there is also something called ventilation effectiveness. Again, Andy will have you in good hands with those descriptions. We have found that even a lot of buildings ended up underventilated anyway. So imposing additional reduction in ventilation rates, and these horizontal lines indicate different levels of standard required ventilation rates versus the ones found in the field, which are these bars. So we found, or actually my colleagues who did the study, peer study, sponsored by the Sloan Foundation, they found a seasonal influence on the bacterial community, which is supports that thesis of indoor-outdoor connection, which is extremely important. But we also found that occupants were very important contributors. And just to give you a very simple example, cooking, no cooking. I know that everybody is looking at human biotaxon, but actually it is what you do in the building that plays a huge role, and how you operate that ventilation system with what rates and what time. And dynamic performance of these buildings is what is really making a difference. Again, we are making a case to measure something impossible. We will reduce our scope eventually to something that is doable, but it's important to discuss what is actually important in general. From that particular, I couldn't resist. I did have a survey, and at least I started ambitiously with really a lot of outcomes that occupants would report after being elbowed by so many retail store managers. I realized I would have to reduce my ambition to just thermal comfort or lighting levels and non-intrusive questions like that. And then I put the fifth question, which was just a toss. Maybe they wouldn't read until the fifth one, and they would let me go ahead. And that was related to the number of, I ended up being really lucky, they didn't strike it. It was related to number of events self-reported in the past 12 months with respect of upper respiratory symptoms, influenza and cold. And what we have found there, it was very interesting. again, we can dissect that study and poke a lot of holes. That's why I've published this only in discussion of a paper. I didn't bother publishing it as a separate paper. We have found that ventilation rates directly influence or were very significant statistically correlated with the ventilation rate. And we found by how much, and again, that's the number that I would not put my life on, but I would certainly tell you that, in fact, these upper respiratory infection rates are influenced by ventilation. And my last piece to close this section, other than dilution, source removal, as long as we can understand the source, is related to filtration. And typically we think about HEPA filters, and again, they're expensive and all of that good stuff, running them. But there is, this work was done together with Steve Rudnick, who did lab experiments with UVGI, upper room germicide irradiation. And there are two species that we looked at. I'm not going to read them. We studied the effectiveness of different UVGI systems. Again, we published 2 or 3 papers. And the part that I would like to bring to your attention is the role that, from the interdisciplinary perspective, from the role that numerical studies can play. My colleague collected only so many data sets that he could from laboratory environment. And then we did a lot of validated numerical simulations for that particular space. This can be done for any kind of building. And what we have found that, contrary to the popular belief, is that the upper UVGI can work nicely and can work nicely even with the lower fan speeds. Having more of higher flow rates through the lab, environmental chamber, having higher fan speeds did not necessarily bring better results in the number of, in a fraction of remaining for that particular 2 species. And we found, in a good old-fashioned engineering way, optimal operation for that space. So bringing people from building science can be very beneficial when you go into the next phase beyond understanding the microbiome and deciding on how to take an action. The other indoor environment, I know I'm broadening the scope, very briefly, is really related to indoor environments in vehicles, because a lot of different types of contagious diseases will be or are already transferred mostly through these points of contacts that do happen in different types of transportation systems. So if you're looking to expand beyond homes and schools, I would encourage the committee to consider vehicles as a point, especially if you're considering mitigation of some of the potential risks for airborne infection transmission. And again, we found a difference first experimentally, then numerically. Again, I'm highlighting the importance of numerical studies of having seated person, having moving people, and so on. So it's not just how you operate your building, but it makes a difference how exposed you are, how, based on how the chairs are distributed, where the ventilation system is positioned, and how close you are to the source. All of that makes a huge difference. You can measure it, but you can also rapidly reproduce a lot of scenarios and do the optimization in a simulation environment. So buildings tend to be diverse with respect to ventilation and occupant population. So microbiome expected to exhibit same trend. I would urge the committee to try to encourage, if not to reach a consensus, on what microbiological organisms would be considered and encouraged to be measured in all of the studies, so that we can cross-reference. I know there was a lot of discussion about methods, and I understand why. When I talk about simulations and things like that, I can spend all my time talking about the methods because they are extremely important for the quality of the data, but for somebody who is outsider that appreciates the work and uses the results, I would really urge the committee to encourage some kind of consensus creation of what indoor microbiome baseline is. And I have here written Cladosporium, which was, for example, the species that was most frequently found in that base study and had the highest concentration levels, just as an example. I really would not know what that cocktail would be a representative mixture of microorganisms for indoor environment. Of course, nobody should limit themselves only to those base species. We should encourage everybody to explore the whole wealth because no consensus can capture everything that is important, and we should explore a broad community of microorganisms. Expected influencing factors other than methods of collection and are certainly building size and type, dynamic ventilation rates and modes of operation, temperature, relative humidity, infiltration rates, occupant population, then sources of indoor microbial and outdoor microbiome. And I would encourage consideration of merging statistical analysis or complementing, when appropriate, with the numerical studies to enhance the understanding of influencing factors and their importance for indoor microbiome, because these environments are heavily driven by what we do, either as operators or occupants in the building. And I would really encourage definition of a base microbiome or something like that, if possible, because that would help other spectators, such as myself, to be able to contribute in understanding what is driving the transport processes in indoor environment. Thank you.
Thank you. Are there some quick questions about this talk?